We have to prove it or to get to know it. So the topic of the argument is going to be, what is the second derivative test? Okay, the second, in application problems, that's going to be our target. This test is much easier. Second derivative test. Okay, I just give an idea of what's going on. Remember, we are interested in the maximum and the minimum. Look at this one that we have. Suppose your curve is going to be this one. You know that at this point, you are going to get a minimum. The previous test that we did, we just check around these points. You see the function is going down, then the function going up. That was the first derivative test that gives the minimum. So what we are going to do in this case is we are going to have a new concept. You see, if you look at because the calculus depends on the tangent line. If you look at the various tangent line for this graph, you see, look at this tangent line or any other tangent line. You will see that the graph of the function is above its tangent line all the time. You see, it's going to be above the tangent line. It doesn't matter, wherever you get the tangent line, it's going to be the same thing. You see, if you get a tangent line over here, the graph is going to be all above its tangent line. If you have a graph of the function with this condition that the graph is going to be above the tangent line, we say this graph is curving up, curving upward, or the other expression is concave. Okay, we say this is going to be concave upward or curving upward. Okay, so the graph is going to be concave upward if it's always above its tangent line. So this is going to be one case. If your graph is going to be the other way around, okay, if your graph is going to be this one, that we're usually looking for the maximum. If you consider the tangent line this time, you see if it's going to be the tangent line. As you can see, the graph of the function is always below its tangent line. Since it's below its tangent line, we say this graph is curving down, curving downward. Okay, curving downward, or eventually we are going to say that this graph is concave. Okay, it's going to be concave, concave down, or concave downward. Okay, so the concave upward would be the graph is going to be above its tangent lines, curving up, and the concave downward is going to be when the graph is going to be below the tangent line. I'm going to define it officially. So a function would be given to you. You have to tell us which one is it. Is it curving up or is it going to be curving down? We are going to learn a test. That test depends on the second derivative. If this is going to be the case, your second derivative of the function, you see, remember f double prime, the second derivative. In this case, the second derivative must be positive. So positive means up, upward. In this case, the second derivative must be negative, which is going to be downward. It's a theorem. We are going to write it down for you to get the, this would take care of the so-called concavity. Okay, concavity, curving up or curving down. This concept is very important in science or in application in everyday life. You see, when you drive on freeway or on the roads, when we get to the curve, you see, get to the curve, your car will bend, if you like, it will be curved, will go around automatically because it's already designed. So for those people who want to design the freeways, they have to be careful about this curve so that you be comfortable. Okay, you cannot have very sharp curve, okay, in some dangerous roads. So how they find out? They find out by the concavity. So this is one of the application of the concavity, or the design of the freeways, roller coasters. Those roller coasters, they got lots of curves. Again, they use this concept that you have over here. Even in eye surgery, they use the concavity to get these numbers, okay? So it's quite important concept, the concavity one. So As soon as we learn it, then we are interested mostly in the maximum and the minimum. Then we have that second derivative test that I talk about it. So what is going to be your second derivative test later is that you see this graph is given to you and you have a critical number, which is C. So what you do is you drop the critical number in the second derivative. You find f double prime of C. You don't need any chart, okay? You don't need any chart. You find f double prime of C. If double prime of C is going to be positive, so this means at C, the graph is going to be curving upward. If it's going to be curving upward, this f of C is going to be a minimum. Okay, this would be a relative, okay, a relative mean. And if your graph is going to be the other way around, if this is going to be the other way around, and this is going to be the point C, in this case, f double prime of C, the concavity, must be downward, must be negative. So easily you just drop the critical value in the second derivative. If it's going to be negative, negative means down. In this case, f of C is going to be a relative, okay, a relative maximum. This would be the second derivative test that eventually we get to it at the end of tonight. Okay, so that's a roadmap of what we are going to do, and eventually then we are going to arrive at the so-called second derivative test. We like this one because it's easy to operate. You just find f double prime and you drop the critical value in it, that critical number. Positive means up, we get a minimum. Negative means down, we get the maximum. So it's very easy to remember and very easy test to apply. Okay, so that's a road plan for tonight. Any question? Now we have to put it into details. Okay, step by step. We define the concavity. We get some example how we're going to determine whether the function is going to be curving up, curving down. This is one problem. And then we get the second derivative test and the maximum and the minimum. Okay, so let's get to the definitions. This was just a summary. So for the definition, we have to define officially what it means by concavity. Okay, so what is going to be okay, concavity of a graph. The graph curving upward or curving downward, exactly as I did it over here. Okay, so suppose we have a function, which is of course differentiable. Okay, suppose we be given a function, okay, a function f. Suppose a function f is differentiable, means you can find the derivative. It must be differentiable, of course, otherwise you can't do it. So suppose a function f is going to be differentiable. Okay, differentiable on its domain or in some interval. On an interval, this is going to be the domain of the function. Interval, let's say I. Okay, interval of 0 to, okay, -1, 5. So that would be the case for the function. Now, if the graph is going to be curving upward, okay, so this is going to be the case. The graph, if this is going to be the case, the first part, the graph of the function, okay, the graph of y equal to the f of x, okay, is going to be concave, okay, concave upward or curving up. Okay, is going to be concave upward if it's always above its tangent line. Okay, on the interval I, if okay, if the graph is going to be, if the graph is going to be above its tangent line. Okay, tangent lines okay, for the point on I, if you like. And it is going to be, and okay,
Can you move it down, please?
that is going to be the case. Okay, so that's it. So the graph is going to be concave upward if the graph is above its tangent line, and it is okay, concave downward. Concave downward if let's say it lies below, okay, below its tangent lines. Okay, very easy operation that we're going to have. So as we did it on the top, so this is going to be the graph. So this is going to be curving upward. And if you check any tangent line, you will see that the graph is above its tangent line. Okay, so this is going to be concave upward graph. Concave upward. Okay, so this is going to be a concave upward graph. And if your graph is going to be curving down, if it's going to be concave one, in this case, we say it's a concave downward. Okay, so a concave down or curving down, downward graph. Okay, so that would be the definition of the concavity, if you like. Now, how we're going to test that? Okay, as we talk about it, it will be related to the second derivative. Any question? I want to go to the next page. Are you done? So, in order to check it, we have a very nice test. You need to have a chart for f double prime, not f prime. So this is the one that we call it concavity. Okay, what is going to be concavity test? So a function would be given. Then you are going to check us, you are going to show us where the graph of this function is going to be concave upward, or when this graph is going to be concave downward. Okay, so this is what we are going to do in this case. Okay, so this is going to be one. What do you want? Do you want me to go back? That is back. Okay, that was the definition that we have. Are you done? Okay, so curving up, curving down for the definition. Okay, so let's go back to the concavity now. How we're going to test that? How we're going to find out? Now we have a nice theorem, and this is how we're going to test. So suppose you have a function. This function must be differentiable. This means you must be able to find the f prime. And also the second derivative of the function must also exist. Not only f prime, you differentiate the function that give f prime, and you differentiate again, that give you the second derivative of f double prime. So both of them should exist to be able to apply this theorem. Okay, so we're going to suppose we have a function. Okay, suppose f is a function. F is going to be a function on its domain, which is a kind of an interval on an interval. Okay, interval I. We have to guarantee that both derivative exists such that, okay, such that f prime, the first derivative, and f double prime. Remember we talked about this one before? So this means you differentiate once, you get the f prime, and you find the derivative of f prime, so that you f double prime. Okay, so suppose f is a function on the interval I such that f prime and f double prime, both of them exist. Okay, exist on I. Because you need to make sure that you are able to find the f double prime, otherwise you can't do it. So the first condition. The first condition is if f double prime is positive. Positive means up, so that you have a concave up. So if f double prime of x is positive. Okay, it's going to be positive, of course, for all x, in the interval I. Then the graph, okay, the graph y equal to the f of x, or of y equal to the f of x, is going to be concave. Okay, it's going to be concave upward, or curving upward on this interval. So you have to check the sign of the f double prime. You may check it, by just using some test numbers. So in order to remember it, this means, you see, positive means up. So this is it. If f double prime of f is positive, the graph is going to be curving upward. Okay, that's going to be one case. Any question? If it's going to be negative, it's the other way around. So the second version is if f double prime of x happen to be negative. Negative means none. Okay, it's going to be negative, then of course for all x, in the domain, in the interval I. If this is going to be the case, negative means none. The graph is going to be curving downward, okay? If this is going to be the case, then the graph, okay, the graph of y equal to the f of x is going to be, concave. It's going to be concave downward. Okay, so this is going to be the second case. So, and this is it, concave down. So this means f double prime of x, f double prime negative. So anytime f double prime is positive, the graph is curving upward. Anytime f double prime is negative, your graph is going to be concave down. Okay, we can use this concavity even to get the graph of the function. Any question? Now, before giving you the examples, there is a third possibility here, you see. And this is positive, this is negative. There are some times that this f double prime of x can be equal to 0. If you get 0, in that case, this x is going to be a special point. This point is going to be called inflection point. So we define that one too, and then we go over the example, because you are going to identify all of them at the same time for us, okay? So what's going to be point of inflection or just inflection point? Okay, inflection points. You see, inflection point is going to be when you go through over the graph, along the graph. So in this case, when you travel, your graph is curving, it's curving down. And then this is going to be curving up. So when you travel, if you get to the place that your graph would change concavity, if you like, or the sign of f double prime would be different. You see, this is negative. If you come here and then you go up again, so there is going to be a place, that the concavity, your sign would be changed. You see, look at this one. Look at this graph. You see, when you travel, the graph is going to be curving downward. But there is going to be a point along here. So when you pass this point, the direction of your graph would be different. You see, there is going to be a place, there is going to be a place that the direction of the graph would be different. This point is going to be called inflection point. Okay, so inflection point is going to be a point where the concavity would change, or the f double prime would change signs, if you like. So this is a definition of a point of inflection. So that's it, a point. Okay, a point or points sometimes. A point on the graph, a point on the graph of y equal to the f of x, okay, where the concavity of the graph, where the concavity changes, means going from the f double prime positive, for example, to the f double prime negative, or the other way around. If it changes, this point is going to be called, okay, it's called an inflection point. An inflection point. Inflection point. Okay, so basically this is going to be the point where the, okay, is going to be the point where this f double prime would change the signs, if you like, to get these numbers, okay, because the concavity would be changed if f double prime would have different signs. So that's exactly what I talk about it. You see, this is going to be the one. So in this case, it's going to be concave down, and this is concave up. So this is where we get it. We denote them by I. It's going to be inflection point. Okay, so your job is going to be, a function would be given. You are going to find an interval or intervals when the function is concave downward, or the graph is going to be concave upward, and they usually ask for the point of inflection. Okay, you do all of them together. So this is going to be the concavity. Any question? So your job would be, a function would be given, and we ask you to check the concavity and the inflection point. As you can see, nothing to do with the f prime. You need f double prime. So you have to give us a chart for the f double prime. In order to get the chart for the f double prime, you find f double prime of x, you let it equal to 0. Then you check its sign by a chart. If where f double prime is positive, it's going to be concave up. When it's negative, it's going to be concave downward. Okay, so this is going to be very easy problem. I'm going to give an example. Any question? Are you done? So one question would be given to you. Nothing to do with the max and the mean. Some people, they make a mistake. They try to find the max and the mean. No, this problem is going to be concavity problem. Okay, don't miss it. One for your next quiz, and then of course on the test number 3. So that's it. We want to find the interval. Find the intervals. You see, for the previously, you find the interval where the function will be increasing, decreasing. And now we get for the concavity. Find the intervals where the graph of this function, where the graph of your function is f of x equal to f of x equal to the x cubed minus 3x, okay, x cubed minus 3x plus 1 is going to be, is concave, okay, it's going to be concave upward, or concave downward, or concave downward. Okay, and then they ask any possible inflection point. Determine. Okay, you are going to determine any possible, because you may not get it. Any possible inflection point. Inflection okay, inflection point. So this is the type of question that you have for the concavity. So nothing to do with the f prime. You need f double prime. So what you are going to do, you are going to find the domain of the function first. As usual, you need the domain first. You see, that's going to be the one. The function is a polynomial, so the domain is all real numbers. Domain is all real numbers. So what you do is you have to solve this equation. F double prime of x equal to the 0. Nothing to do with f prime. Because you want to check the concavity, and the concavity is related to the f double prime only. Any question? So differentiate. You have to find the f prime first, and then you differentiate it again, so that gives f double prime. So we go with the f prime. F prime, derivative of the function, that gives you 3x squared minus 3. You're not going to stop here. You continue. Go to the f double prime. So you differentiate it again. 2 times 3 is 6, 6x. This is what you need. F double prime of x. You see, f double prime of x. You let it equal to the 0 to get those possible inflection points. So f double prime of x, okay, f double prime of x equal to the 0. So this means 6x must be 0. And of course, x would be 0. Okay, so x would be 0 divided by 6, which is equal to the 0. So x equal to the 0, this is a possible inflection point. Okay, since the inflection point, you must give us the x and the y coordinate. You better drop this 0 back into the function, then you have to test it, because you need a test to tell us where the function is going to be concave upward or downward. Okay, so find f of 0 in the function. This is your function if you replace the x by 0, so that gives 0 plus 1, which is equal to 1. So f of 0 is equal to 1. So the possible inflection point would be the point 0, 1, but not yet. Any question? So we need a chart. We need a chart for the f double prime. You see, we call it f double prime chart. Okay, this is it. The first part is x, just the number line. Okay, starting from negative infinity to positive infinity. The numbers that you're going to check is the one that you got from here in that inflection point. So the number is going to be 0. Okay. So in this part, you are going to put f double prime because you want to check the sign of the f double prime. And f double prime is 0 here. Okay, it's going to be here. And f of 0 is equal to 1. Any question? So you partition the number line, about, okay, or around the possible inflection point that you get. So if double prime equal to the 0, x would be 0. So this is going to be a number line from negative infinity to positive infinity, that's 0. This is f double prime. We put f double prime equal to the 0, we get the 0 here. So we have to put the 0 here. And here is just, okay, y coordinate of the 1. This last part is concavity. You have to give us the direction of the, okay, the direction of the curve. Okay, any question? To get these numbers done. Okay, this is going to be the 1. F of 0, we replace the x by 0 to get f of 0. X is equal to the 0. You drop it back into the function to get f of 0. Because this is going to be a point. F of 0, this is it. You let f double prime equal to the 0, you solve it, we get x equal to the 0. F of 0, you go to the function, you replace the x by 0. You replace the x by 0, that's it. 0, 0, 1. So f of 0 would be 1. Now you have to check the sign of the f double prime. Okay, you have two partitions, 1, 2. So you bring f double prime. You see this is going to be f double prime of x, which is equal to the 6x. So you need the numbers to test it. You see, you need one number to test in this region and one number to test in this region. So this is going to be negative number. So you pick a negative number. Any number will be fine. So for example, I picked a negative 1. Okay, you drop the negative 1 into the f double prime. So f double prime of negative 1 would be what? Would be 6 times negative 1, which is a negative 6. So this means in this region, f double prime is what? Is negative. Negative. Okay, so you have to check one number here. Number must be a negative because it's between negative infinity and 0. So I picked a negative 1. It doesn't matter. You can pick negative 2, negative 5. We don't need the value. We just need the sign. So any number that give you a negative here. Okay, any question? So in that this part, f double prime is going to be, okay, f double prime is negative. You know that when f double prime is negative, your graph is going to be what? Concave done. So you have to give us a shape of the graph, you see, concave done. Okay, so we put the negative 1 into the f double prime to check the sign of the f double prime. And if f double prime is negative, the graph is curving down. Any question? Go to this one. You pick another number between 0 and positive infinity. So 0 and positive infinity, for example, you can pick any number you like. For example, 1. Okay, so if you pick the 1 here, any positive number will do it. So we go to the f double prime again. That gives us the f double prime of what? F double prime of 1, which is going to be 6 times 1 is 6. This time is positive. It's positive, so this region is going to be positive region. So f double prime positive, you know that f double prime positive, the graph would be curving upward, curving up. That's it. So this graph is going to be concave down between negative infinity and 0, and concave up between 0 and positive infinity. If you give us the chart, you don't need to explain anything for us. Next, do you have an inflection point or not? You see, this is the candidate. As you can see, the direction of the curve are different. You see, this is your curve. So the direction is different at this point. So this means this point is an inflection point. Okay, so we can say that I equal to the 0, 1 is going to be an inflection point. If you see, if you run this number, the concavity are going to be the same if both of them is going to be curving upward or both of them curving downward. In that case, you are not going to get the inflection points. So it's not the case that always you will get the inflection points. You have to, some people, they don't test it. They get the f double prime, they let it equal to the 0, and they claim the result to be, okay, inflection point. No, I can give you easily a function that you let f double prime equal to the 0, but your point is not going to be an inflection point. So you got to be careful. You have to give us this result, okay? So the table is self-explained, but if you want to explain it, this is it. You don't have to explain if you give me this nice chart, but officially this is going to be the version. So the graph is going to be, okay, it's going to be concave. It's going to be concave downward on this interval, negative infinity and 0, and is going to be concave upward on this interval of 0 and positive infinity. See, if you want to, sometimes, it's going to be a question in your book, at the end, you want to check the solution. So probably this is the way they talk about it. But if you give us the chart, we are happy about it. And then you don't have to explain anything extra for us. Okay, any question? So that is the first problem. Remember, in this problem, nothing to do with the maximum or the minimum. Some people, they waste their time. They find the maximum, the minimum. No, this is another problem, not this one. Concavity, you just give us the shape of the graph. It would be useful if you want to get a precise graph of the function. So in that case, you are going to use the concavity. Okay, any question? But the target was what? Second derivative test. Now we are ready to give you second derivative test. As we talk about it at the beginning, we find the critical value, okay? As usual, critical number. Then we are not going to use the first derivative test. The second derivative test would be the C, the critical number. You drop it into the F double prime. If F double prime of C is positive, positive means upward. Up, we get the minimum. If it's going to be negative, and down, we get the maximum. Very easy test. Okay, let's write it down. That would be the second derivative test. Okay, so this is something that in order to get through the second derivative test, we need it and we get it free really. Okay, so what is that famous second derivative test? Okay, for some function that we're going to have, exponential function and the natural log, then it would be very crucial to be able to use one of these tests. For some of them, it would be easier to use the second, or sometimes it would be easier to use the first one, okay? So what is the second derivative test? So theorem, okay, second derivative test. Second derivative test. Okay, second derivative test, or we abbreviate it as second derivative test. Now, what's going to be this test? We have a critical value and we want to test it. Your function need to be twice differentiable because you have to go to the F double prime, okay? So we are going to suppose F is differentiable. F is a differentiable. Okay, F is a differentiable function. Okay, suppose F is a differentiable function on the domain on the domain D, such that F double prime, of course, exists on D. Because you should be able to go to the F double prime. You see, you may have a function that's going to be only differentiable. There is no guarantee that if you can find the derivative of the function once, you'll be able to continue to get to the second one, okay? So it's just for guarantee. So what's going to be the question? The question is, you give me a critical number, I test it for you. There you are. If C is going to be a critical number, So this means you already let F prime equal to the 0, okay? And you find your C. But you don't know whether you get a maximum or a minimum. That's the situation that you have. Okay, if C is going to be a critical number of F with, this is where you find it, F prime of C equal to the 0. So this means you let F prime of X equal to the 0 and you get this C. If this is going to be the case, there you are, you have two possibilities. The first one, you find the second derivative and you evaluate it at C. if f double prime of c is going to be positive. Remember, f double prime is concavity. Positive means up, up, we get a minimum. So if f double prime of c is positive, then f of c is going to be is a relative. Okay, it's going to be a relative minimum. Minimum. That's it. You see, that's the reason. Because when f double prime is positive, the graph is concave upward. Concave up, you get a minimum. Okay, you get a minimum here. So you get a minimum if f double prime of c is going to be positive. Question? So that's very good. You don't need any chart. You just directly plug in. Okay, plug in c into the f double prime. That's case one. Case two. If f double prime of c, okay, if f double prime of c happen to be negative. Remember, concavity, negative means it's curving down. So we get a maximum. If this is going to be the case, then f of c, okay, f of c is a relative, okay, relative maximum. Maximum. Okay, there you are. So it's easy to remember because f double prime negative, negative means down. Down, we get a maximum. In order to get the down, f double prime of c must be negative. Very easy test to get these numbers. No chart is needed because it's just a substitution. Any question? There is a third possibility. Okay, the third possibility is that you find f double prime of c, then that would be 0. You see the third one? If f double prime of c is 0, you'll be in trouble. Because if it's 0, this means this is a wrong test. You cannot use it. You have to go back and use the first derivative test. Okay? So in this case, we say the test fails. The test fails. Use the first derivative test. There are some problems in your book, and they ask you to determine if the second derivative test can be used. So for those problems of your book, if you get this situation, you say that, oh, the test fails and cannot use it. But if you are the one who just, you choose to use this test to find the max and the minimum, your test would fail. You are not done. You have to go back and get the chart of the f prime to get the max or the minimum. Some people on the test, they use this one and they say the test fails. They don't continue. Yes, if the test fails, it's your test. Okay, your test fails. So you better change it into the first. It's very rare, okay, for your case, because we have mostly polynomials and the polynomials are nice. But yeah, there are a couple of cases that you may have used, you may have used a wrong test. So no problem. You go back and you start it over to get to get through this problem. Okay, that's it. That's a second derivative test. Any question? So we are going to check it. On the test, there are two possibilities. The one that you are going to pick the test, but there are going to be the one that we are going to give you the instruction. So if you ask you to apply the second derivative test, you have to, okay? So that would be the situation we're going to have. We have some very nice function that we can apply this easy test. So let's start with one of them. This is going to be example. Let me just go to the next page because I need more rooms. Any question? Are you done? Very easy test. Concavity, positive up, negative down. Up, minimum. Get this shape, then you can find out. F double prime, concavity, up, minimum. F double prime, negative, negative means down, down, maximum. Okay, this is it. Now the example, we want to check the test, see how easy it is. Okay, we give you the instructions, so you have to. So apply. Okay, apply the second derivative test. So the instruction is given. Apply the second derivative test. Second derivative test. Apply second derivative test to find, okay, to find relative, okay, extrema. Okay, relative extrema, remember, it means the maximum limit of the function, Okay, let's check the first one. The function is, there you are, f of x equal to, f of x equal to the x cubed minus 9x squared plus 24x minus 10. Okay, this is going to be your function. So you know that you have to find critical values first, candidates. You find the critical values, you drop it back into the function to get the candidate. Then you have to test it. In general, you have two choices, the first derivatives and the second, but in this case, they give you the second. So you have to apply the second one. Okay, so this is the way we're going to do it. So what is going to be the solution? Domain first, remember. It's a polynomial. So the domain would be all real numbers. Find f prime. F prime, easy to find. That gives you 3x squared minus 18x plus 24. Double check, because this is the important part of your problem. If you miss something in f prime, everything would be, would be different. Okay, I just used the power rule, 3x squared, 2 times 9, 18, plus 24. You highlight it because you have to use it quite time. You let it equal to the 0 to find the critical numbers. So that gives you 3x squared, okay, minus 18x plus 24 equal to 0. You have to solve this equation by factoring. You can pull out the 3 as a common factor and then continue. So we pull out the 3 as a factor, that gives x squared minus 6x, okay, plus 8 equal to the 0. Now we can factor the inside. We need two numbers with the product of 8 and a sum of 6. So it's going to be 3 times x minus 4 times x minus 2 equal to 0. So you let each factor equal to 0, 3 equal to the 0, never. You won't get anything from here. But x minus 4 equal to the 0, that would give you x equal to 4. This is going to be one critical value that you have. And then x minus 2 equal to the 0, that gives you x equal to 2. So you have two critical numbers. Okay, so the critical numbers are going to be, you have the 2 and the 4. 2 and 4. That is step 1. Any question? So this is the one that you have to do for all the problems that we have. Now drop it back into the function because they are the candidate for the max and the min. Okay, go to the function. This is the original function. So find f of 2 and f of 4. That's the next step. F of 2 into the function. That gives you 2 cubed minus 9 times 2 squared plus 24 times 2 minus 10. Okay, 2 cubed would be 8. 2 squared would be 4. 4 times 9 would be 36. 2 times 24 would be 48. And the minus 10. Okay, I just substitute. So get these numbers together, 8 and 46. 48 would be 56. And this is going to be 46. Okay, so the difference is going to be equal to 10. Okay, so that will give us, so f of 2 equal to 10. This is one candidate, or a maximum or a minimum. Any question? Get the 4. Okay, f of 4. Drop it back to the function again. Okay, this is it. It's going to be 4 cubed. The function was minus 9x squared, 9, 4 squared, 24x, 24 times 4, and minus 10. Okay, we substitute into the function. Okay, 4 cubed, 4 times 4 would be 16. 16 times 4 would be 64. Minus 4 squared would be 16. Okay, would be 16, and the 9 times 16. Okay, so that give you negative. Okay, that is going to be the case, and 9 times 6 would be 54, 144. That's the one. Okay, 144. Then 4 times 24. 4 times 4 would be 16, 96, and minus 10. Okay, I'll just do the algebra to get these numbers done. Okay, what's the question? To get these numbers. What do you mean? We find the numbers. You see, we find the numbers. These are the critical values. We did it before. You have to find these are the x values. You drop the x values into the function to get the value of the function.
So you would like never put it in the derivative?
No, because if you put it in the derivative, the result would be 0.
Oh, okay, I see.
You see?
Yeah.
Because you let it to be 0 to get it, okay? So if you put it, you know, it's going to be, you're not going to get any new information, okay?
Okay.
Because you're talking about the max and the minimum value of the function, not the derivative, okay? So that's why you have to put it into the function, okay?
Thank you.
Okay, any question? Let's check this one to see what we are going to get. So it's a 64 and the 96 that give 160. Okay, it's going to be 160 minus 154, I think. So that gives you 6. Okay, so f of 4 is equal to 6. You see, these are the candidates. One of them should be a minimum. The other one should be maximum. Some people, they say, oh, I don't have to check it. This is 6, this is 10. No, you have to test it. Okay, now the testing. You have two choices, the first derivative or the second. Remember, the first derivative, you have to give us a chart for f prime. But in this problem, they ask you to use second derivative test. Okay, so you're not free. So in this case, we say testing. Okay, and most of the time, the second derivative is easier. So the test or testing. So in this case, second derivative test. So for the second derivative test, you have to bring the f double prime. Okay, so what is going to be f double prime? You go to the f prime. Where is the f prime? You see, look at the f prime. This is f prime. You differentiate f prime this time. It's going to be 2 times 3, 6x minus 18. So we go and we bring the f double prime of x. So the f double prime of x would be 6x minus 18. Okay, this is f double prime. You want to check the concavity. You drop the critical value in it. You start with the 2. Okay, if you put x equal to 2, you test these two numbers. If you put x equal to 2, okay, x equal to the 2, so f double prime of 2 would be what? 6x, 6 times 2 minus 18. So that gives you 12 minus 18, which is a negative 6. It is negative. Remember, this is f double prime. F double prime is concavity. I write it down here again to explain it. You see, you get the negative number. So the negative means what? Negative means down, curving down. Concave down, remember? Curving down, that give you the maximum. So this means f of 2, which was equal to the 10, okay, is a relative, is going to be a relative maximum value of the function. Any question? So you test the number into the f double prime because this is going to be a number c. So that's x equal to 2. We have one more to check, x equal to 4. If you drop x equal to the 4 into the f double prime of 4, the result would be what? That is 6x minus 18. It's going to be 6 times 4 minus 18. So that gives you 24 minus 18. This time it's going to be positive. Okay, so f double prime of 4, 6 is positive. But remember, f double prime is what? F double prime is your concavity. So this means that the graph of the function is what? Positive means upward, upward. So we get the minimum. So this means f of 4, which was equal to the 6, is a relative. Okay, it's going to be a relative minimum. And you are done. Very nice test, very nice one. And you will see some more interesting function in future to get these, these numbers around it. So that would be a type 1. I'll give you a break now. And we come back, we give you one more, and we give you one that you cannot use it. So that don't be surprised when you do the problem in your book. Okay, so the order of this problem, order of the operation is very important. The first part is like any other problem that you did before. I call it 50%. The part that you let f prime equal to the 0, you see f prime equal to the 0, you find your critical values and you drop them back into the function. This is the part that we did before. But the new part is testing, that we decided to use the second derivative test. So you have to find the second derivative, f double prime. You test these numbers into the f double prime. If f double prime is positive, means it's curving, okay, it's a negative curving down. If you get a curving down, as you can see, you have a maximum. So that f of 2 equal to the 10 is a maximum. If it's going to be a positive, means curving upward. So f of 4 equal to the 6, okay, is going to be a relative minimum. Okay, let's have the break. We come back. We give you 2 more examples, especially one of them that you cannot use this test. Okay, that's it. This is second derivative test. Okay, it's almost 8:20. Let's have about 10 minutes. We come back. Okay, I'm going to give you another example. This example is going to be very typical one for this type of function. Okay, so let me see, yeah, to see what would happen if sometimes you may not be able to use this test, okay? But most of the time, you know, it's a very safe test, but you have one problem. I think you have one or two in your book. So let's see what you do when you get to that situation, okay? So this is going to be the second function. You want to apply the first derivative test to check. So the function is f of x equal to f of x equal to 10x to the 6, okay, minus 24, 24x to the 5th, and plus 15x to the 4th. This is a function, and you want again do the same thing. You've been asked to apply the second derivative test to find the maximum and the minimum, okay? So solution, start with the domain. It's a polynomial, so the domain is all real numbers. So it's going to be R or real numbers. So we find the derivative of the function will be equal to 0. So that's it. It's going to be f prime of x is equal to, you differentiate it carefully. A power rule, 6 times 10 would be 60. So that gives you 60x to the 1 down, which is going to be 5. And the minus 24 times 5, which is 120. So it's going minus 120x to the 4th. And the next one is going to be 5 times 15. 5 times 15 would be 60. So we get 60, okay, it's going to be plus, okay, plus 60x to the 3rd. So this is going to be your f prime. Okay, you let it equal to the 0 to find the critical values, f prime of x equal to the 0. So the equation that we have to solve is this one, 60x to the 5th minus 12x to the 4th. Okay, plus 60x to the 3rd equal to the 0. You have to solve this equation. You look for the common factors. Okay, this is of course 120. Okay, the common factor for the x would be x to the 3rd, and for the number would be 60. So we pull out the 60x to the 3rd as a factor. So the leftover over here, 60 would be out, x to the 5th and x to the 3rd. The result is going to be x squared. X squared and 120 divided by 60, that give you 2, so minus 2x. Okay, and plus 1. Okay, this is it. Is going to be plus 1 equal to 0. Any question? Just factoring to try to solve this equation. We factor the terms inside, just go on, 60 x to the 3rd. You need two numbers with the product of the 1 and a difference and the sum of 2. The numbers are going to be x minus 1 and x minus 1 equal to the 0. Okay, negative 1 times negative 1 would be positive 1. And if you add them together, that gives you negative 2x here. So you let the factor to be equal to the 0 to find the critical values. You see 60x cubed equal to the 0. You divide by 60, so that gives you x cubed equal to the 0. And then you cube root, you take the cube root. So in that case, your x would be 0. So this would be one critical number. Any question? Now we have more factors. We have x minus 1 equal to the 0. So that gives you x equal to 1. And the factors are the same, so we get only one number. So these are going to be our critical numbers. So the critical numbers are going to be two numbers, okay, 0 and 1. That's the step one. Any question? So we find the f prime, it is equal to 0. The degree of the x is a little bit high. It doesn't matter, we look for the common factor. You see the common factor for the x is going to be x to the third. And all of them are, all the coefficients are divisible by 60. So that's why I pull out 60x cubed. Now the next step is you are going to drop these critical values as we did it before into the function, and then you test it. Okay, so we are going to find f of 0. If you put the 0 in the function, you get 0, 0, 0, 0. So f of 0 would be 0. Okay, this is going to be your f of 0. Okay, then you find f of 1. So what is going to be f of 1? If you drop the 1 into the function, you see, if you drop the 1, that gives you 10 minus 24 plus 15, which is a 25 minus 24. So the result would be 1. Okay, so f of 1 is equal to 1. So these are two candidates for the maximum and a minimum. So we want to know which one is the max, which one is the mean. We have to test it. We have two cases, two choices, second and the first. You've been asked to second, so testing. Okay, we use the second derivative test because you've been asked to do it. So for the second derivative test, you need the second derivative. So you need the f double prime of x. If it's going to be first derivative, you just focus on the f prime. Okay, so what's going to be second derivative? Is it going back? This is the derivative of the function. Okay, this is the derivative of the function. So for the second derivative, you have to continue the power rule. It's going to be 5 times 60, which is 300, x to the fourth. This would be minus 48, x to the third, and this is going to be 180 x squared. So this is going to be f double prime. The first one is going to be 300 x to the fourth. Okay, the next one is minus 480. 480 x to the third plus 120. Okay, 180 is going to be plus 180 because it's going to be 3 times 60. It's going to be 180 x squared. That is going to be your f double prime. Any question? We just differentiated. You see that's f prime. Just using the power rule. 5 times 60, 300. 1 down, x to the fourth. 4 times 120, 480. 1 down is going to be x squared. And the 3 times 60, 180. 1 down would be x squared. Okay. Now we test the numbers in it to see if it's going to be maximum or the minimum. If we put the 0, what are we going to get? You see x equal to the 0, that gives you f double prime of 0. But all of them got x, so f double prime of 0 would be 0. Remember, if f double prime is 0, you cannot use this test. Because you can use it if it's going to be positive or negative, remember, because you talk about the curving upward or curving downward. So this means this test fails, and you have to pick another test to be able to continue. Okay, so as soon as we get the 0 here, you see, we said the test cannot use the second derivative test. Okay, so the test, the second derivative test. The second derivative test, okay, fails. Okay, so you're not done. So this is a wrong test. So what you can do is, if you want to continue, one can apply or one should apply. Okay, so one should apply. one should apply. Okay, one should apply the first derivative test. The first derivative test. Derivative test. Okay, so we have to find the bearing the f prime again. So what is the f prime? This is the f prime. As I told you, it's rare, but it can happen. So we have to be prepared for it. Okay, so we apply the second derivative test as we've been directed, if you like. But we didn't get any result because this must be positive to having the curving upward. Or it's going to be negative curving down. This happened to be 0. So for the first derivative test, remember you have to give us a chart. This is going to be the chart. Remember the chart was, we start with the x from negative infinity to positive infinity. We're testing the critical values. So the critical values are going to be 0 and 1. 0, 1. Okay, we tested f prime now. F prime. This is f prime. F prime is 0 at 2 places, here and here. And then we put the f of x here, remember, f of x. So f of 0 is equal to the 0. And f of 1 is equal to 1. This is what we have so far. Okay, so we have to find the sign of the f prime this time. You see, 1, 2, 3. So you have to test some numbers into the, okay, into the f prime to see what is going to be the sign of, okay, what's going to be the sign involved to check these numbers. Okay. The second derivative test fails because it's equal to the 0. You see, in the case of the first derivative test, the second derivative test, you must have a positive number or a negative number. Because it's going to be positive, your graph is going to be curving upward. If it's going to be negative, your graph would be curving down. We talk about it when we discuss the test. You see, that's it. Your test can work only if f double prime is positive or the negative. You see, curving up, curving down. If it's going to be 0, you cannot say anything. That's why you are going to check the, okay, you change your test going to the first derivative test, okay? So it's very rare, but I give you one example that this is going to be the case. Okay, so yes, second derivative test is equal to the 0, so the test fails. Now, going back to this one, you have to identify the sign of the f prime. You can test some numbers, but get some help. You see from 0 to 1, it's a kind of increase. So this is already positive. That will help you. You're just checking 2 numbers here. Okay, you check 1 numbers here for the f prime and 1 number here. So you can test something like a -1 into the f prime. You see, this is your f prime. If you put the -1 into the f prime, you see this is going to be yes, in the f prime. What is your f prime? That's your f prime, of course. You see, this is the f prime. So if you check the -1 into the f prime, what's going to be the result? The result, -1 to the 5th would be negative, so that gives you -60, -140, and then -60 again. So it's going to be -60, okay, minus 120, and the positive 60. Okay, that gives you f for the -1. Okay, so in this case, these 2 would cancel out. You get -120, which is a negative number. So this would be negative. Negative means down here. Okay, so I put the -1 here. Then I should check a number here between 1 and positive infinity. I pick something like 2 here. If you put the 2 into the f prime, you must get, you'll be surprised when you get the 2. Let's try it. If you find f prime of 2, go to the f prime substitute, that gives you 60. Okay, it's going to be a big number. It's going to be 62 to the 5th. Okay, 62 to the 5th minus 120 2 to the 4th. Okay, and plus 60 is going to be 62 to the 3rd. You see, that's going to be the number. Okay, yeah. You can check these numbers. Okay, you can use your calculator to get it, and eventually this is going to be a positive number. Okay, this would be a positive number, so this is positive again, and it's up. You see, so 1 was a critical number, but nothing happened around the 1. It's up, up, up. So you are going to have only a minimum. So f of 0 equal to the 0 is a relative. Okay, it's going to be relative mean. So that's a situation. It's very a special function, of course, that you get the critical value, but you won't get anything. And that's why the second derivative test, fails for that case. Okay, most of the time it's nice, you get the solution. Of course, you didn't have to do it because they ask you apply second derivative test and you say it fails and you're done. But I just did it so that you know what is going to be what's going to be the alternative. If you use it yourself, okay. If you use it yourself, you say, oh, sorry, I did the wrong test. So I go back and I check it if you like. Okay, so this is going to be second derivative test. Any question? So it's much easier than the first. Okay, you find the derivative of the function. You have to literally consider to get the critical values. Okay, that's the one. Then you go to the second derivative test. You are going to drop these critical values into the second one. If it's going to be positive, because the second derivative gives you concavity. You see concave upward or concave downward. So if the critical values is positive, like the one that we did, the previous one, that give you minimum, the other one will give you the maximum. Okay, any question? So that is the application of the first and the second derivative test. On the test, sometimes you have a choice, and sometimes, okay, you have to decide yourself. We are going to need it when we get to the log function and the exponential function. For the time being, it's all easy one really. So I just check the one in your book to see what type of problems. We are going to apply it quickly to get this result. Let me tell you the one in your book, which is going to be, okay. We are going to give you polynomials only because for the rational number, it takes a little bit more time to do it. So you have some in here. Okay, this is section 3.3 that you have to pick up all of them as your assignment. Okay, so there is a one here, number 23. They just put the red light here. So we just check it to see what will happen with this one. Okay, so I'm going to write this one as a third example. Just double check it for you. It's going to be the one that you're going to have on the test, straightforward. So let's see why in your book they put this one as a red one. So this example is going to be number 23 of the section 3.3. going to check it to see if it's anything special about it. So you have the f of x is equal to, the function is x to the fourth, okay? The function is going to be x to the fourth minus 4x cubed plus 2. The question is the same. They ask you to use the second derivative test, okay? Second derivative test to find out the maximum and the minimum. Okay, are you ready? Solution, of course, the domain first. Domain is all real numbers because it's a polynomial. Okay, check the f prime. Carefully differentiate it. F prime of x. So that gives you 4x cubed. 3 times 4 would be 12 minus 12x. That's your f prime. Okay, I'm going to highlight it because I'm going to use it. Okay, let it equal to the 0. F prime of x equal to the 0. So you have to solve this equation, 4x cubed minus 12x equal to the 0. We use factoring, of course. You have a common factor of the 4x. Okay, so we get that is going to be the, oh, I missed a square here. 3 times 4, 12, so that gives you 12x squared, yes. It's a 4x cubed minus 12x squared, okay? So that would be x squared. To get these numbers, it's going to be easier now to handle it. Okay, yes, thank you, Parker. So we factor out, the common factor is x squared, 4x squared. So 4x squared out. So the leftover is going to be what? Is going to be x minus 3 equal to the 0. Okay, and this is again one of those steps that you have that difficulty. That's why in your book they mark it with the red. Okay, so let the 4x squared equal to the 0. 4x squared equal to the 0. You drop the 4, that gives you x squared equal to the 0. So this means x is 0. Okay, one critical numbers. And then x minus 3 equal to the 0. So that gives you x equal to 3. So we have two critical numbers. Critical numbers are going to be 0 and 3. Any question? So double check, the derivative, make sure that everything is all right. So that was the derivative. Let it equal to the 0, the common factor for x squared. That gives x minus 3. So these are going to be our critical values. Drop them back into the function, then test it. Okay, drop back to the function. So that gives you f of 0, x equal to the 0. So we are going to find f of 0. So it's going to be f of 0. F of 0 into the function, that gives us a 2. So this is one candidate. Okay, check x equal to 3. X equal to 3. So we check f of 3. Go to the function, substitute. So that gives it 3 to the 4th. Okay, 3 to the 4th minus 4. 3 to the 3rd plus 2. Okay, 3 to the 4th would be 81. Okay, 81, the 3 cube would be 27. Okay, 4 times 27. Okay, this is going to be, I think it's 108. That give you 28, yes, 108, and plus 2. Okay, then it's going to be what? It's going to be 83. 83 minus 108, so the result is going to be a negative, and that gives us a 5. Okay, this could be the 525. Okay, so f of 3 is equal to the negative 25. So these are all your candidates. Okay, f of 0 equal to 2, f of 3 negative 20. Any question? Now we want to test it. They suggest the second derivative test. Okay. Test or testing. They suggest the second derivative test. So we have to bring the second derivative. So bring the second derivative. Carefully differentiate again. See, let's see what we have. This is the f prime. So if you get the second derivative test, 3 times 4 would be 12. So that gives you 12x squared. Okay, minus 24x. So that would be your second derivative. Okay, and now bring the numbers. You see the number is going to be 0 and 3. So if you check 0, you say x equal to the 0. If you check the 0, that gives you 0, 0. You see, you stop. Second derivative test cannot be applied. That's why you see it with the red sign in your book. You see they say find all relative extrema of the function. Use the second derivative test when it is this is it. Use the second derivative test when applicable. So in this case, it's not applicable. So it doesn't mean you are done. So you have to go back, change the test. Okay, so the second derivative test, because you cannot say whether it's positive or negative because it's a 0. Second derivative test cannot be applied. Cannot be applied. Okay, so you have to change the direction. So you change your direction and you are going to use the first derivative test. Okay, so the first derivative test, you need the f prime. What is your f prime? We bring the f prime down here to have it handy. 4x cubed minus 12x squared. That's f prime. So we need to have a chart this time for the f prime again. You see, x is like the one that I did. F prime of x and f of x. So this is from negative infinity to positive infinity. The numbers that you have to test are going to be critical values. You have the 0 and 3. This is 0. This is 3. F prime is 0 at 0 and 3. And you have the f of 0. F of 0 is equal to 2. Okay. F of 0 equal to 2. And f of 3 is negative 25. Okay. It's going to be, it's like the one that I did for you. This is negative. So far this is going down. So again, you have to check 2 numbers here, you see. So this is negative so far. So you have to check a number here like a -1. And you have to check a number here like a +4 if you like. Okay, you have no other choice to get this true. So -1, f prime of -1. What is f prime of -1? That gives you 4 times -1 cubed minus 12 times -1 squared. -1 cubed would be negative, so that gives a -4. -1 squared is positive, so that gives a -12. So that would be -16. So in this case, you see, in this case, it is f prime is negative. So it's going down. You see, look at this one. So again, this means f of 0 equal to 2 is nothing. It's not a maximum and it's not a minimum, and you don't be surprised. That's why your second derivative test fails. Okay, and so we have to check a number here. This would be something. This would be a minimum. So we check f prime of 4. F prime of 4 into the f prime, so that gives 4 times 4 cubed minus, okay, minus 12 times 4 squared. Okay, 4 cubed is 4 times 4, 16. 16 times 4 would be 64. So it's a 4 times 64. 4 times 4, 16, 256. And over here is going to be 16 times 12. Okay, 16 times 12, or that's that, 48 times. So what is going to be 16 times 12? 16 times 12 would be 190, okay, 192. This is positive. Okay, F prime positive, so this would be positive. So that would be up. So you have only a minimum. You see, so F of 3 equal to the negative 25 is going to be a relative, okay, a relative minimum. So as you can see, these examples are important.
For F, derivative 4 is the answer 64. I don't think you put an answer.
For what? F
F,
prime of 4?
you just put 256 minus 192. You didn't put the
It's
answer.
positive. You don't need the result.
Oh, okay.
You can write it down. How much is it? 64? Thank you. Yes, 64, and it's positive. You have to make sure you don't get a positive number. Okay, so don't be surprised. You may get a situation that you see your test may fail. Okay, so be ready for it. As I told you, it's very rare, in the examples that you have in your book. This is the only one. And that's why they mark it as a red number. Okay, so to finish the argument that we did tonight is, so that was one problem. The other one is concavity. Make sure that don't mix them up when the problem would be given to you on the test. They are two different problems, okay? Two different problems. So that's why I give you one again. So you compare them together and you know what we are expecting you to do it. When they say the maximum and the minimum, you go through all these ideas. But if they ask only for concavity and the inflection point, you just stay with the F double prime, nothing to do with the F prime. Okay, so I give you this last one again from your book. Just make sure you compare them together and you're not going to miss these two problems. Okay, so what they ask you to do is, I write it down in this format. You see, they want to find, okay, find the point of inflections, okay, find the point or points of inflection of this graph, okay, of I'm going to pick one of these, okay, again from your book, just to explain it for you. So I pick number is going to be 15 and 14. Let's try 14. Okay, so your function is going to be f of x. Just to make sure that you have both of them together, so you're not going to be confused on the test. Don't waste your time too much. So this is going to be 32. And this number is from your book again. It's a section 3.3, and it's a number 14. Just make sure you get a couple of the numbers. You have the numbers in your assignment, but this is what we expect you to do for us, okay? It's going to be 20 points for the next test. Okay, so you want to find the inflection point. So what you have to do is, you have to do, you need f double prime. You let f double prime equal to 0. Those would be the candidates, okay? So nothing to do with the max and the min. So we start with the domain first. It's a polynomial, so the domain is all real numbers. Okay, so you go with the f prime as usual first, f prime. You differentiate it, that give a negative 12x squared, okay, minus 16x. But you are not going to do anything here, okay? You are not going to let it equal to the 0. because you are looking for what? Inflection point. So you keep going. You have to go to the F double prime. Okay, so we go to the F double prime. We differentiate again, so that gives us a negative 24x minus 16. We stop here. Okay, you let it equal to the 0 to find the possible solution. So F double prime equal to the 0. F double prime equal to the 0, we have a negative 24. X minus 16 equal to the 0. Solve for x. Okay, add the 16 and continue. Negative 24x equal to 16. Okay, x would be what? X would be 16 over negative 24. We can simplify it by, okay, by 8. So that gives us a negative 2/10. Okay, so x equal to the negative 2/10. This is x values of probably, okay, the inflection point. But you have to go back and drop it into the function and then test it because you are interested in the points, okay? So you find f of negative 2/3 into the original function, okay, so minus 4 times negative 2/3 to the third minus 8 negative 2/3 squared plus 32. Okay, you have to be patient to get it. It's going to be a negative 4. Negative 2 cubed, this is going to be negative 2 cubed would be 8. 3 cubed would be 27. Okay, the sign would be negative because it's a third power. 2 cubed, 2 times 2 times 2 would be 8. 3 times 3 times 3, 27. And this would be minus 8. 2 squared, it's going to be positive number, it's going to be 4, 9. And the 32. Any question? Just, linear algebra. So it's going to be equal to, you multiply the top, that give you 32 over 27. And this would be negative 32 over 9. And the 32, let's have 32 here. You have to find the common denominator. The common denominator would be 27. So that gives you 27, 32. That would be 27. You have to multiply the top by 3, 96. And 27, it's going to be a big number. Okay. To make it into the 32 is going to be 32 times 20, 27. Okay, can you use a calculator? Get these numbers. Okay, 32 times 27. We are going to give you a nice number. This is from your book. So it's going to be 864. Okay, so eventually f of negative 2/3 is going to be equal to, okay, what's going to be the result? Is going to be equal to, subtract these two first, negative 27, 32 out of 96. So that give you 2 out of 6 would be 4 and 64. And this is plus 864 over 27. Okay, if you subtract it, that gives you 80 over 27. Okay, so it's not a nice number, but it's just a number. This is the candidate for the inflection point. Some people on the test, they stop here and they claim that this is an inflection point. That's why I did solve this problem for you. No, it's not the case. You have to test it first. It's not the case that any of these solutions are going to be your inflection point. You need the test and show that the concavity would be changed. So you need the concavity table. X from negative infinity to positive infinity, you're testing only negative 2/10. This is going to be f double prime. and this is concavity. The first problem that we did. Okay, f double prime is 0 here. And the value is 800 over 27. You bring f double prime and you test two numbers. What is f double prime? It's a negative 24x minus 16. You need two numbers to find out where this is going to be positive or where this is going to be negative. Okay, we just take two numbers. What's the question? How did I get 8 common denominator? You see, this is 32 over 1. And I want the denominator would be 27. So I have to multiply the top and the bottom by 27. So I 27 denominator, the top 27 times 32 would be 64. Okay, to get your common denominator. Okay, now test the two numbers, two easy number. So for example, we can test the -1 here. Okay, it's easy, f prime of f double prime of the -1. Make it 24 minus 16, which is 8, is positive. So this would be positive. Positive means concave up. Okay, you need to test a number here. You can test a positive one. So if you put the positive one, that gives me negative 24 minus 16. Okay, which is going to be negative 40. It's negative. So this is negative means concave down. Up, down, this is inflection point. So your inflection point is negative 2/3, comma, 800 over 27. So make sure you remember, you have to test it. You need the table. So that's the two problems that I introduced it at the beginning and I did it at the end. Concavity and the second derivative test. All of them would be given to you in your next quiz, which is in 2 weeks' times, and on the test. On the final, I'm not going to give you concavity. We just give you one question and ask for the second derivative test. And that's it. That's a section 3.3. So now we have all the information to be able to find the maximum and the minimum. The next step is going to be a couple of application, okay? We have a section, we call it optimization problems. So we focus on the revenue function, profit functions. So when the profit is going to be maximum or the minimum. I just give a couple of examples of this one. And quickly we finish this chapter because we need to get to the next chapter. We're introducing two famous functions, the log function and the exponential function. And that's, we get quite a lot to work with those two functions. So that's why we want to finish this chapter as quickly as possible. That's it. Any question? So check this question on the 3.3. Okay, I've already graded everything you did before. So I try to grade your test maybe by Tuesday. I try. So we can check that one and then be prepared for your next quiz. Okay, have a good night and take care. Bye-bye.
Thank you.